Hello dear viewers, welcome to TV Math Hub. In our today's session we shall be looking at question 16 for Ginger Joint Mock. It says the curve has gradient of 2x minus y upon x and it passes through the point which is 3, -1. We need to find the equation of the curve. So we are given the gradient and we know that gradient is same as having dy dx. So it means that we have dy dx which is equal to 2x minus y divided by x. So this will give us a differential equation. So let us try to have this equation written in the form of dy dx plus y upon x, which is 2x. So looking at this, we can easily see that we have dy dx plus 1 upon x of y, which is equal to 2x. If you recall very well, this differential equation is of the form dy dx plus p of x, then y, which is equal to q of x. So when you compare this and this, you realize they are of the same format. And for that case, this is what we call a linear ordinary differential equation. And you know how to solve linear differential equation is by using what we call an integrating factor. So that is the same thing we shall apply to this equation. So we shall let our integrating factor to be, for example, lambda, which is equal to e to the power of p of x. P of x for this case is 1 upon x, then dx. So this is same as integrating 1 up e to the power of, we are integrating 1 upon x, and you know whenever we integrate 1 upon x, we get ln of x. So this will give us x e. Now, having got your integrating factor as x, you will multiply it into this simplified expression, and it will be same as having x dy dx plus y, which is equal to 2x squared. So when you multiply integrating factor into this expression, you will be able to get a main function or a function that was differentiated to give you the left hand side. So what is the main function? So the main function will be same as x integrating with respect to y, a function of y with respect to y, but the function of y which is here is only 1, so dy. So this will be same as 2x squared. So in other words, your main function can be obtained by getting your integrating factor, then you integrate the function of y that will be here, and there it is only 1, then dy. So this will give you x y. So that is how we can easily get the main function. So meaning that our main function, which is xy, when you differentiate this main function, you will get the left hand side, that is x dy dx plus y, and this is equal to 2x squared. So from here you can integrate on both sides. So let us have integral of this with respect to x, and we do the same on this with respect to x. So when we differentiate x of y and at the same time integrate it, then we shall remain with the xy, and this will be equal to 2x to power 3 divided by 3, then plus c. So that is basically what we shall have. So from here we are told that the curve is passing through the point 3, -1. So let us look at the point 3, -1. So at this point, your x is 3 and your x is 3 and your y is -1. So having got that, then we can obtain the value of c by substituting x and y in this given expression. So 3 times -1 is equal to 2 into -1 to power 3 divided by 3. This is 3. So that is 2 times 3 to power 3 divided by 3, then plus c. So this is -3, which is equal to, this is 9, that will be 18 plus c. So meaning that c is same as -3 minus 18, and c will be -21. So we are getting c as -21. So let us return it back at this given point. So when you put it back at that given point, you will get, so we are having xy, which is equal to, so we shall have xy, which is equal to 2 out of 3, x to power 3 plus c, which is -21. So from here you will have y equaling to 2 over 3 divided through by x. This is x squared minus 21 over x. So therefore let us conclude that the equation of the curve, therefore the equation of the curve is, therefore the equation of the curve, the equation of the curve is, so it will be y, which is equal to 2 out of 3 x squared minus 21 over x, and that will be your answer. Now looking at part B, it says solve the differential equation x squared dy dx plus y, which is equal to x squared e to the power of 1 upon x. We are given that y is equal to 2 when x is equal to 1. So looking at this differential equation given, you realize it is almost similar to what we have simply done in part A. So what we shall do is to make sure that we put this differential equation in the form of dy dx plus p of x of y, which is equal to q of x. So doing the same, we shall divide through by x squared, and we shall have dy dx plus 1 upon x squared y, which is equal to e to the power of 1 upon x. So likewise, we shall look for the integrating factor. So the integrating factor will be the integral will be e to the power integral of p of x, but for this case p of x is 1 upon x squared dx. So this will be same as e to the power of integral of x to power negative 2 dx, and this is same as having e to the power of, integrate this, you only integrate this, increase the power by 1, divided by the new power, so this will be x to power negative 1 divided by negative 1. So this will be same as e to the power of negative 1 over x. So this will be our integrating factor. So having got the integrating factor, now multiply it into this simplified equation. So when you multiply it there, it will give us e to the power of negative 1 upon x dy dx, then plus e to the power of negative 1 upon x over x squared y, which is equal to e to power 1 over x times e to power negative 1 over x. So from here, you will obtain the main function. And how do we obtain the main function? We obtain the main function, or the function that will be differentiated, to give you the left-hand side by simply having the integrating factor, which is e to power negative 1 over x. Then you integrate the function of y that will be at this given point, and that is only 1 with respect to y. So our main function will be e to power negative 1 over x, then y. So meaning that when you differentiate the main function, which is e to power negative 1 over x of y, you will get what we call the whole of this expression. So for that case, d dx of this will give us e to power 1 over x plus that times e to power negative 1 over x is same as getting this 1 over x plus negative 1 over x, which will give you e to power 0. E to power 0 is 1. So from here, what we shall do is to integrate on both sides with respect to x. Dx, then also this side 1 with respect to x, and this will give us, e to power negative 1 over xy, which is equal to x plus c. So this is what we shall get. When you differentiate this function and you integrate it at the same time, you will remain with the same function. That is e to power negative 1 over xy, which is equal to x plus c. So from here, we are given x is 1 and y is 2. So let us have that. We are having e to power negative 1 over xy, which is equal to x plus c. But we are given that y is 2 and x is 1. So we shall substitute for that. E to power negative 1 over 1 times 2 is equal to 1 plus c. So this is same as e to power negative 1, then times 2, that is 2 e to power negative 1 is equal to 1 plus c. So from here, this is 2 upon e to power 1 minus 1, which is equal to c. So this is same as having 2 minus e to power 1 upon e to power 1, which is equal to c. So that will be the value of c. And that for that case, we shall have e to power negative 1 over x of y, which is equal to x plus 2 minus e to power 1 upon e to power 1. So that will be our expression. So you can have this as e to power negative 1 over xy, which is equal to x plus, so you can simplify this given expression. So when we try to simplify this, we shall be able to get that, and this can be now finally written as y, which is equal to e to power 1 upon x. That is when we divide through by e to power negative 1 over x on both sides, then minus 0.26424, then e to the power of 1 upon x. So this is basically what we shall get as the answer. Yeah.